All right, so this is section 3.5, which talks about point slope form, and this is very helpful for the discussion this week because in order to write your equation for a line, you're going to want to use point slope form. And actually, now that I'm looking at it, I have my slideshow on the wrong screen, so I'm not on the screen where I can write my notes. So let me switch that up. I want to make sure that I'm on the screen where I can actually use my tablet. This is what I get where I have too many screens going. There we go. Okay, so now I've got it on my tablet so I can actually write. So for equations of lines, we basically have three different ways you can write the equation. There's standard form, where you have your x and y on the same side, and that is used when we solve something called linear systems. That is not something we're covering in this class. That is covered at the very end of college algebra and is focused on in pre-calc. We have slope-intercept form, which is the best form for graphing because it's really easy to see how much it's changing by. You can see where it crosses the y-axis, so that makes it really easy for graphing. And then the last one, which is from this section, is point slope form. And this is the best form when you have to write an equation of a line. So this is the recommended form. So it's y minus y1 equals m times x minus x1. The y1 and the x1, those come from 1 point. So if you have to find your slope, then whatever y1 or whatever x1, y1 you have in your slope is going to be the same value you use here. And then, of course, m is our slope, just like it is in slope-intercept form. So all you need is a slope in 1 point in order to write the equation of a line using the point slope form. So best way to do this is just with lots of examples. So we're going to use the information given to write the equation of a line. So for the first one on the left, the slope is equal to -2. So I'm going to just label m is equal to -2. And the line passes through 1, -5. So that's going to be our x1 and our y1. So we get a single ordered pair. We're labeling them as 1 because they're just the first point. It's the only point we have. So the equation for slope or point slope form is y minus y1 equals your slope m times x minus x1. So you're going to want to plug in your numbers. So y minus y1 and y1 I have labeled as -5. So we're subtracting a -5. And then we have our slope, which is -2. So I'm going to plug that in for m. And then we have x minus x1, and x1 is 1. So we're subtracting 1. So we have y minus -5 equals -2 times x minus 1. So when you're subtracting a negative, the y minus -5, that's y plus 5. And then we get equals -2 times x minus 1. Now we usually write our answers in slope-intercept form. So we don't keep it in this form. So to put it in slope-intercept form, you need to distribute. So we need to multiply the -2 through the parentheses. We need to multiply by both the x and the -1. So that gives us on the left y plus 5. And then we get -2 times x. And then -2 times -1 is a +2. So you get -2x plus 2. And we want this in slope-intercept form, so we subtract 5 from both sides so that it's solved for y. And you get y equals -2x, and then 2 minus 5 is -3. And so that is our equation of a line. It has that particular slope and it goes through that single point. So I'm going to bring up Desmos so we can see this graphed. So I'm going to put in my slope-intercept form that I just solved for. Y equals -2x minus 3. So that's the slope-intercept form. We want to verify that it passes through 1, -5. So I'm going to type in that ordered pair. And you can see that that point is on our line. So that means this line does go through that point, and so this is a check to make sure that you have done it correctly. So we have the right slope because in our slope-intercept form we have a slope of -2, and then we do have it going through that point. So this can check your work. Are there any questions? Okay, so let's do the second one here that I have. It's a different slope, and we're going through a different line. So our slope is 5 in this case, and then our x1 is -1, and the y1 is -3. So we're going to be using the same point slope form, so I'm going to just highlight it. This is the formula that I'm plugging into. And it's good practice to write that down because that helps you memorize the formula and to see what you're plugging things into. So y1 is -3, so I'm going to have y minus -3. My slope is 5. Then x minus, and x1 is -1. So all of these subtracting and negatives I'm going to rewrite as adding. So it's going to be y plus 3 equals 5 times x plus 1. And now I'm going to distribute the 5 through the parentheses here. So I have y plus 3 equals 5x plus 5. So I'm solving for y because we want this in slope-intercept form. So I'm going to subtract 3 from both sides. We get y equals 5x plus 2. 5 minus 3 is 2. And so that's the equation of the line. It has a slope of 5 and it goes through -1, -3. Are there any questions? Okay. So here's where things get a little more complicated, and this is similar to what you have to do on the discussion because now we're writing an equation of a line that passes through 2 points. We're not given the slope. So we have -2, 5, and 0, 1. In order to write the equation of the line, you always need the slope. So the first step is to find the slope. So I'm going to just label my x1, y1, and my x2, y2. So our formula for slope is m equals y2 minus y1 over x2 minus x1. So y2 is 1, y1 is 5. Then x2 is 0, and x1 is -2. So we have 1 minus 5 over 0 minus negative 2. So 1 minus 5 is negative 4. 0 subtracting a negative 2 is 0 plus 2. So we get negative 2, or negative 4 over 2, which divides to negative 2. So now that we know the slope, now we can write the equation. And this is where we're going to use our point slope form. So point slope form is y minus y1 equals m times x minus x1. So I'm going to write this to the side, y minus, and we're going to use the same y1 that we have as our ordered pair. So I'm going to use 5, because that's what I labeled as y1. And then m, we just found m, that's 2. And then x minus x1, which is negative 2. So we have x minus a negative 2. So this is y minus 5 equals negative 2 times x plus 2, because we're subtracting a negative. So I'm going to distribute, because I want to solve this for y. So I get y minus 5 equals negative 2x, and then we get a negative 4. Negative 2 times 2 is negative 4. We're solving for y, so we're going to add 5 to both sides. And this gives us y equals negative 2x. The negative 4 plus 5 is 1, so that's plus 1. So let's double check this one. Let's make sure that we have this correct. So I'm going to pull up Desmos again. And I'm going to clear out what I have. And I'm going to start by putting in the equation. Y equals negative 2x plus 1. Now I want to double check that it goes through both ordered pairs. So I'm going to type my first ordered pair, negative 2 comma 5. Okay, and that is on our line. We can see the point right there. And then we want to plug in the other one, 0, 1, to make sure that's also on the line. And you can see that is also on the line. So if you're given 2 points, you want to double check that both of them are on the line. If they're not, that means you made an error on the slope. So if only one of the points is on the line, your error is on the slope. If the slope looks correct, but the line doesn't go through them, that tells you made an error on the equation. So that's a good way to troubleshoot where you might have messed up. So if the angle between the 2 points looks the same, but it's not going through them, then your equation's messed up. Your slope is okay. Are there any questions? Okay, let's do another one. We're going to write the equation of the line that passes through 1, negative 3, and negative 7, 2. So I'm going to start with my slope. And I'm going to label my x1 and my y1 and my x2, y2. My x is not looking like a good x. There we go. So slope is y2 minus y1 over x2 minus x1. So this will be 2 minus a negative 3 coming from the y values, and then negative 7 minus 1. So 2 minus negative 3 is 2 plus 3, so that's 5. Negative 7 minus 1 is negative 8. So we're going to have a fraction here. Now the equation of the line, we have y minus y1 equals our slope m times x minus x1. So I'm going to plug in my x1, my y1, and my slope. So y minus y1, which is -3. Our slope is -5/8. And then x minus x1, which is 1. So the y minus -3, that's going to be y plus 3. And I can also distribute the -5/8 through the parentheses. And when you do that and you're multiplying by a whole number, you just multiply the top of the fraction. So this will give us -5/8x. And then a negative times a negative is a positive, so we're going to get a positive 5/8. So we want to move the 3 to the right. So we need to make sure that it has the same denominator as 5/8 because we have to combine it with the 5/8. So a whole number is always over 1. So I need a denominator of 8. So I need to multiply the top and the bottom by 8 there so that I can get a common denominator. So I'm going to just move to the right. So this will give me y plus, and 3 times 8 is 24. So 24/8 equals -5/8x plus 5/8. Now that we have a common denominator, I can subtract 24/8 from both sides. So I get y on the left, I have -5/8x, and then we're going to just subtract the tops. 5 minus 24 is -19, so I get -19/8. And that does not reduce, so then that is your final answer. We don't want to convert these to decimals because we want to use the real number. We want to use the exact value. If you round, you're no longer using exact. The only time when you'll want to make these decimals is if it's a real life problem. So for the discussion, that's a good time to actually divide and make it a decimal because we're working with real numbers. And so it makes more sense to use the decimal version than the fraction version. But if you have a problem and there's no context, it's not a word problem, you're going to want to keep it as a fraction. Are there any questions? Okay. So now let's take a look at writing equations for lines with things that are perpendicular and parallel. So we're going to find both. We're going to get a single line here, y equals 3x plus 1. And we want to find an equation of a line that's parallel to it and that's perpendicular to it. And we want these to go through particular points. We want it to go through 4, -1. So if you're recalling from the section on slope, parallel lines have the same slope. And perpendicular lines are negative reciprocals. So it's the reciprocal and it has the opposite sign. So in order to write the equation of a line, we need to know the slope from the given line. So our given line, it's in slope-intercept form, so that is equal to 3. So the value in front of x is the slope. So for the parallel line, we're going to use a slope of 3. For the perpendicular line, you're going to use the opposite sign, which means it's going to be negative, and then you take the reciprocal. So that's going to be negative 1/3. We're going to have it pass through the same exact point. We got 4, which is x1, and then negative 1, which will be y1. And we're going to use point slope form. Y minus y1 equals m times x minus x1. So we're going to use this form to write our equation of a line, and we'll graph it at the end to verify. So I'm going to do the parallel one first. So y minus y1, which is negative 1, equals slope 3 times x minus x1, which is 4. So y minus negative 1 is y plus 1. And I'm going to distribute 3 times x is 3x. 3 times negative 4 is negative 12. Then I'm going to subtract 1 from both sides. And we get y equals 3x minus 13. And this line is going to be parallel. So I'm going to pull up Desmos, clear out what I have. So first I'm going to graph the given line, y equals 3x plus 1. So that's the line that they gave us. Now we're graphing a parallel line. So now I'm going to put in my parallel line, y equals 3x minus 13. So you can see that these have the same slope, so they're not going to cross. So these are parallel. And I also want to double check it goes through our point for negative 1. So I'm going to put that on here as well. And so it does go through the point. So you can see that now I have an equation of a line and it's parallel. So the blue line is our answer. It's parallel to the red line. And it goes through the point, which is green, so it fits all of our requirements here. Now let's look at the perpendicular line. It's basically the same thing, it's just going to have a different slope. So we have y, and I already know y minus negative 1 is going to be plus 1. So I'm going to write y plus 1 equals negative 1/3. And we have x minus 4. Now I know that I'm going to have a fraction with a denominator of 3 here, because I'm going to get, when I multiply it with my fraction, I'm going to get a denominator of 3. So I'm going to be multiplying the 1 by 3 over 3 so that it has a common denominator. So I'm going to have y plus 3 over 3 equals, now I'm going to distribute as well. We get a negative 1/3 x plus 4/3. So 1/3 times 4 is 4/3. So I'm going to subtract the 3/3 for both sides. And this gives me y equals negative 1/3 x plus 1/3. Now this is going to be perpendicular. So I'm going to pull up the Desmos, and I'm going to clear the parallel line. And we want to make sure it's perpendicular, so it's going to form a right angle. So I have y equals minus 1/3 x plus 1/3. So you can see it does look like it forms a right angle crossing the red line, and we verify it is going through our point for negative 1, that green point right here. It does cross that point, so we've got that verified as well. So if you verify that it looks like it's forming a right angle and it goes through your point, that means you now have the line that is perpendicular to the original line that we started with, and it goes through for negative 1. Are there any questions? Okay. This is actually my last example. We're going to do another parallel and perpendicular, but the line we're given this time is not in slope-intercept form. So we're given 5x plus 3y equals 6, and that needs to be in slope-intercept form, and it's not. So we need to solve this for y before we do anything else. So that means subtracting 5x from both sides, which will give us 3y equals, and I like to put the x first, minus 5x plus 6. And then we're going to divide everything by 3 so we can get that slope. So y is equal to negative 5/3 x plus 2. And the value in front of the x is the slope. So this line has a slope of negative 5/3. So that means for the parallel line it's the same, so that's also going to be negative 5/3. But for the perpendicular it has the opposite sign and then it's the reciprocal. So it's going to be positive 3/5. So once you've decided that, once you've determined that, then you just need to use your point slope form, which is y minus y1 equals m times x minus x1. So this is actually going to be easy for us because the point they're giving us has a y1 value of 0. So it's going to make our life a lot easier. So for the parallel line, I have y minus 0 equals negative 5/3, and then parentheses x minus 2, since the x value is 2. So that means on the left I just have y, and all I need is to distribute. I need to multiply through the parentheses. So I have a negative 5/3 times x, so that's just negative 5/3 x. And then I have a negative 5/3 times a negative 2, so that's going to be positive. And you do 5 times 2, which is 10, so we're going to get 10/3. And that does not reduce, and we've already got it solved for y because the y value, the y1 was 0, so that's your equation. So it's going to be equally as easy on the right with the perpendicular. We have y minus 0 equals 3/5 times x minus 2. So there's a different slope, but it's still going through the same point. So I get y equals, and 3/5 x, then 3/5 times negative 2. So it's going to be a negative. And you do 3 times 2, which is 6, so you end up with 6/5. And that does not reduce, so that is your answer. And you could graph both of these. You can graph your original line, the 5x plus 3y equals 6, and you can verify. Desmos actually doesn't care what form the line is, so we can do that. So the original was 5x plus 3y equals 6. Our parallel line is y equals negative 5/3 x plus 10/3. So you can see that it's parallel. And 2, 0, you can see it marks it because it's an intercept. It does go through that point. If we want to check the perpendicular line, y equals 3/5 x minus 6/5. So again, it marks 2, 0 because it's an intercept. So it goes through our point and it does look perpendicular. It has a right angle there. So you can verify that you have that correct. So this is my last example. Are there any questions?